Hi, welcome to Chapter 10 in Python. This is probably my favorite chapter of the whole book. It's when we get into basically object-oriented programming. Object-oriented programming is a very powerful. These first few pages of the slide, or first few pages of the book are, I don't know, they're just kind of obscure and really don't get to the point. But we'll just cover them, and then we'll get into the meat of it here in just a second. So we're going to cover procedural and object-oriented programming. We're going to talk about classes, working with instances, and then techniques for designing classes. So the first thing, procedural programming, and that's pretty much what we've been doing so far. It's just writing code where it just basically goes execute a line, execute a line, execute a line, execute a line, execute a line. That's pretty much what it does. With object-oriented, we're going to create these things called objects. Now think of an object as this glob of data, and it basically is going to hold data. We can actually store data inside of it, and then we actually has executable parts. We've kind of seen some of these, like with the pickle, with the dot load and the dot dump. The dot whatever, that is the method. So the pickle part is an object. And then we can store data inside of that object, and then like the dot dump and the dot load, those are the methods that actually execute against the data we're giving them. And that whole thing of having everything inside of that glob is known as encapsulation. So we have an object and we have data attributes, and think of those as the place where data is stored. And then we have these methods, and these are things that actually execute, that actually do something. I like to call the data attributes the nouns, and the methods are the verbs. So the nouns hold something, and the verbs actually do something. Now, one of the nice things about classes and objects is we can do what's called data hiding. Those attributes that we have over here, well, we can hide those from the person calling that class. We don't want them to have direct access to that, because when you have direct access to that data, you can modify it outside of the class. We want them to use the class and the encapsulation to actually set the data and actually get information from that data. Another great thing about these objects is reusability, and it'll make a lot more sense once we get into it. But once we create this, and I think it's the but the nice thing about it, it's kind of like a blueprint for a house. We can create the blueprint for a house, and we can build a house from those blueprints. We can build a second house and a third house and a fourth house. And the nice thing about that blueprint is each house can have its own type of door, its own color of paint. We can actually move walls around and then basically say that I want to basically make this room a little bit bigger and that one a little smaller. When we can do that, when we create this class that we build objects from. Again, it'll make a little more sense once we get into it. And so like I said earlier, we have our object that has our data attributes. They hold the data, and the methods actually execute and do something, most likely with that data. And then we're going to have code where we're actually going to call this object, and we're actually going to use this object to create objects from it. So this object is the class, basically. The class is the blueprint. We're going to create objects from this class from code outside of there. So data attributes, those are basically the parts that hold the data. For example, if we had a clock object, we would have a second, a minute, and an hour. They hold those numeric values for those pieces. We have public methods, and these allow the code to be manipulated. So basically, a method has to be public. So when we're outside of that class and we call that class, we have to be able to get in and execute those methods, so they have to be public. We can also have private methods. Now, the thing about a private method is it can only be executed within inside that code. So let's say, for example, I have an object that creates some kind of a tax, calculates some kind of a tax. Well, I might have a method that just does the tax calculation. I don't need to use that outside of that class. It's used internally within that class, so we would make that private. We don't want to be outside of that class to have actually access to that. So again, so classes, that's the code. Think of it as the blueprint that we're going to create these objects from. When we create an object from that class, we're going to create what's called an instance of an object. So we need to create an instance of that class, which becomes an object. So again, like I alluded to earlier, the class is the blueprint, and again, we can create. In this case, we created 3 houses from this one blueprint, and that's basically what a class is. So, and here's an example of that. I can have an insect class, and from the insect class, I can create a housefly object, or I can create a mosquito object. It basically has the same data attributes and the same methods, but again, there's differences. We can create different types of objects from that class. So the class definition is a set of statements that defines a class's methods and data attributes. So that's basically actually creating the blueprint. And it starts with class and then the class name. The class name often starts with an uppercase letter. So whenever we see an uppercase letter, that tells us that it is a class. Methods, method definition is like any other Python function definition. We're going to use the DEF. One thing, for every method inside of a class, we will use what's called the self parameter, and that basically is the object itself. We always have to include the object itself within it. And again, this will make a little more sense once we get into it. We do have what's called an initializer method, and that is a method that automatically gets executed when we do an object instantiation. So when we create an object and that object is formed or instantiated, that init method is automatically executed. So we're going to get right into the an example here in just a second, and it's basically the coin object. So the coin object, we create it. It's created in memory, and as it's created or instantiated, this def init program method is automatically executed, and then again, notice it's got the word self in there. That says that is the object itself that's been created, and we've got a data what do they call that? Data attributes. The data attribute is called side up, so that's the part that holds the data, and we're going to put the word heads in there. And then we got our coin object, and the side up right now has heads. So when we first create this coin object, it's going to set the side up data attribute to the string heads. So to create a new instance of class, we call my instance equals the class name. To call any class methods, we basically say the name of that instance dot the method. And we've seen that, just like with the pickle, we have the dot load and the dot dump. Because the self parameter references specifically, so it is the actual instance of that object that's been created. And so, okay, and that's passed automatically. Hiding attributes and storing classes. An object's data attribute would be private. To make sure this, we place 2 underscores in front. It's hard to see that there's 2 underscores right there. So whenever we have 2 underscores in front of a method or a data attribute, that means that is private. It can only be seen inside of that class. Anything outside of that class cannot be seen. Classes can be stored in modules. Okay, so let's get right into it. And we're going to be right here on page 526. And we're going to look at the coin class. So let's go ahead and open up the coin class. Now, I want you to know right now, this class is not executable. If I basically come down here, there is nothing. If I tried to run this, if I tried to do a right click and say run coin, it would basically it won't do anything because there's nothing there that's executable. We're going to create an object from this class. So you notice it starts with the word class, and notice the C in coin is uppercase. Here is our init method. Notice it's got the 2 underscores in front. That means it is hidden. Nobody can see this outside of this class. So when we instantiate or create an object, this will automatically be executed. Now notice I've got /_ side up. That is a hidden data attribute. We can't see that outside of there as well. So we have heads. Now we come down here, we have def toss. Notice now here's kind of a rule. All of these methods have to have self inside of the parentheses. We have to have access to the instance of the object itself. Okay, so that's what that self means. That says, hey, the object we've just instantiated, we have access to it right here. Notice I've got self dot __ side up. So that's the data attribute. Remember, data attributes hold data. Right now we put the word heads inside of it. So when we instantiate this right off the bat, the data attribute side up has the word heads in it. Now I've got toss. That's a method. It's executable. When that is called, it's going to create a random number. Now, see this A:, B:? PyCharm puts that in there automatically. So you can ignore those. So really all it shows is 0, 1. It says we're going to start with 0 and go to 1. So it's going to create a random, either a 0 or a 1. That's all we want. And if it's equal to a 0, if the random number that comes back is equal to a 0, we're going to set side up equal to heads, else we're going to set side up equal to tails. Now, the question you should be asking is, so you've created this hidden data attribute, how do we get access to it? Well, we've got this method called getSideUp. Again, remember we always have to put self in the parentheses, and we're going to return self.sideUp. So if we call this, it will return the value. It won't return the side up itself. It will return the value that's inside of side up to it. Okay? So that's the class. Well, how the heck do we use it? Well, we're going to look at, I'm going to be on page 529, and we're going to use the coin demo 1. So, right here I've got import random, and what we've done in this particular case right here, we've actually included the class directly into the code. And I'll show you here in the next couple examples how we can use it outside of the code. So right now I've got this class coin, and then down here I've got my def main, and down here I can actually call that def main. So let's look at main. Okay, we've already seen the class coin. This is the same exact code that was in the code we just looked at. So in here I've got my coin equals coin. This is where we instantiate the object. This is where the object is created. Now remember, when it's instantiated, this init program is automatically executed. So what it does is it creates a data attribute called sideUp, and it sets it to the word heads. Okay? So after line 34 is created, that code is executed, that init code is executed, and now we've got an object sitting there with a data attribute called sideUp, and it has the word heads in it. So then we're going to print this sideUp, colon, and we're going to then call mycoin.getSideUp. So it's going to call this guy and return what's inside of there. And again, in the init program, it always sets it to heads. So it's kind of like we're getting ready to flip the coin. We put the coin on our thumb, and we've got the heads setting up right now. Now I'm getting ready to toss it. So to do that, I'm going to print I am tossing the coin, and then I've got mycoin.toss. So it's going to call this, which basically gets a random number, either a 0 or a 1. If it's a 0, it's going to make side up to heads. Else it's going to make it tails. Then I print this side up, mycoin.getSideUp. So it's going to call that getSideUp again and display what's there. So now when I run this, it comes back as this side up heads. So that's where we're setting the coin on our thumb and set it to heads. I'm tossing the coin and it comes back heads. If I run it again, oh, now this time it's tails. Run it again, tails, 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 tails. Wow, tails, heads, heads, tails, tails, heads. So you can see it's basically that random number generator is bringing back a 1 or a 0 just randomly. Okay, so review, we've instantiated an object right here on line 34. The object is called my coin. That my coin now has a side up data attribute. Since that init method was called, it now has the word heads in it. When I come down here and I say get side up, it will return heads, whatever that side up attribute holds. Down here, toss gets that random number, 1 or 0, and basically returns heads or 0. And then down here I can say my coin.get side up, and then it displays that. So we're going to display 3 things. What we start with is heads. I'm tossing the coin, and then what we get after we toss the coin. Just kind of a side note, if you're familiar with Java programming, this init program is basically a constructor. So if you're familiar with Java, that's basically what that is. Now, on page 532, we're going to have the coin demo 2. Now, I found out, if you've probably downloaded the code from the book, you're going to find out that it doesn't work. And the reason it doesn't work is, I'm going to comment that code out. I'm going to go ahead and try to run this. And it basically can't find the coin. So what I had to do was add this code right here on line 3. I put from coin import coin. So it's basically say from the coin.py. So from this guy right here, I want you to import the coin class. Okay. So now you'll notice we do not have that coin code in here at all. So that coin code is now in its own file, but I've imported it. And now I say my coin, so it's the same exact code. The only difference between this code and the previous code is we do not have that coin code inside of here. It's a separate file. So I instantiate my method right here. My coin equals coin. Notice uppercase C. I basically do the print the side up. It's got the heads in it. Then I basically toss the coin. And then down here I basically, then it says, but now I'm going to cheat. I'm going to directly change the value of the object's my side up attribute to heads. So my coin dot side up equals heads. Let me see. Will it work? Yeah. Now, let me back up a little bit. And here's why it didn't work. Is I'm going to do this. I'm going to take these 2 underscores out. Okay. I'm going to take these 2 out and these 2 out and these 2 out. So now when I do this, I'm going to go back over here to coin demo 2. Now on line 20, it says my coin.sideUp equals heads. I'm going to run it again. And that will always be heads. This is always going to come up heads because I have direct access. I have direct access to the data attribute side up. We don't want that. We don't want anybody to have direct access to that. Because this is what we can do. We can actually change my coin.sideUp to heads. And now we've basically kind of lost the whole reason why we have an object. So again, we want to come back over here and make sure that we put 2 underscores in front of side up. 2 underscores in front of side up. And do that for every time we deal with side up. And now And now this guy, it's no longer usable. It will not, we don't have direct access to side up. So now when I basically do a coin toss, it's going to ignore this line and basically says, sorry, I can't execute that line. So now when I run it, notice I'm getting tails right down here. I see tails, I see heads, so it's working perfectly. So again, we do not want anyone to have direct access to our data attribute. That's why we hide the code inside of the class using the 2 underscores in front of the name. That way there, it's hidden inside of that, which nobody else has access to it. Okay? And that's basically, that's really what demo 3 does, is it basically does that. It has the side up, has two underscores in front of it, and basically, so we just basically covered that. So now, on page 535, it talks about storing classes and modules. This is programmers commonly organize their class definitions by storing them in modules. Modules can be imported into programs that need to use the classes they contain. So we're going to leave coin as is, and we're going to open up this demo, coin demo 4. And what we've done here is this time, now we saw in my coin demo 2, where I said from coin, import coin. Well, what we're doing in 4 is we're just saying import coin. So it's going to take whatever is, so we've seen that before, how we import one item into another module. And so I said import coin. And now down here when I say my coin is equal to, notice I say coin dot the class coin. So it says take this module coin, and I want you to import this class. Remember, classes start with an uppercase. So now we've got an object. And so we pretty much have the same exact code we've seen in the past, except this time what we're doing is, because remember, the init program always starts with heads. So when I basically execute line 11, it's going to print heads again. But this time it says I'm going to toss the coin 10 times. And this time I'm going to use a for loop in range 10. So it's going to start with 0, go up to 10. And we're going to say my coin dot toss, and we're going to print get side up. And since side up is hidden, we cannot access it directly. All we can use is the method, because the method is public. We can use the method to get that whatever data is inside that data attribute. And then it's going to basically do that 10 times. So now when I run this, there it is. I got tails, tails, heads, heads, tails, 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 heads, heads. And if I ran it again, we'd probably get totally different. Look at that. Heads, tails, 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 and the rest are heads. So again, totally random at that point. Okay. Now, the next thing we're going to talk about is the bank account class. And class methods can have multiple parameters in addition to just self. For the init parameters, we needed to create an instance of the class. For example, a bank account object is created with a balance. So the init program just has self in it. We can also put other parameters inside those parentheses. So example, the bank account object created with a balance. When called, the initializer method receives a value to be assigned to the underscore underscore balance. Remember, we want our data attributes to be hidden, so we put the underscore underscore in front of them. For other methods, parameters needed to perform the required tasks. For example, deposit method is the amount to be deposited. Okay, so let's go ahead and take a look at that. Again, this is on page 537. So I look at bank account. And again, this is a class, so it's really not executable. So here's my init. Now notice with my init, again, we always have self, the object itself, and we've got BAL. So it's expecting something to be passed to it, when we instantiate the object. And then we say self underscore underscore balance is equal to bal. So in this particular case, we're expecting the user to pass something to it when we instantiate it. Something has to be passed to it. We do have a def deposit where we have self and amount. So we're going to pass. So whenever we call deposit, we also have to pass an amount to it, and we're going to make the balance equal that amount. So if we're doing a deposit, we want to add to our balance, and that's why we do the plus equal. We have a withdrawal. Now we got to do some safeguards when we do withdrawal. Again, we have to pass an amount, but we have to say underscore underscore balance. We have to make sure that it's greater than or equal to the amount, because we can't withdraw more than what we have. So if the balance is greater than or equal to the amount that we passed in, this is the amount we want to withdraw, then we're going to go ahead and say balance minus equal amount. So we're going to subtract the amount from the balance. If that is false, we're going to print insufficient funds. And then we have get balance. So if somebody needs to get the balance that we currently have in our account, we're going to call this method, and it's going to return whatever is in the balance. So we are going to call this with the account test. I'm on page 538. And so here we have our main. That's the only method we have. And we've got our start bal is equal to float input, enter your starting balance. So we want to float because we're going to have decimal points. And now we're going to create our bank account object. But notice up here we do have import bank account. We have to do that for it first. We have to have access to that bank account class code. So we go ahead and say savings equal to bank account dot uppercase B bank account. Remember, this is the class. And notice that we now include the starting balance, because remember that init is looking for an amount to create a starting balance for the account. Then I'm going to say pay is equal to how much were you paid this week, and it says print, I would deposit that into your account. And then we say savings, and this is our class, this is our class object, and we're going to call the deposit method, and we're going to pass in pay, and that will automatically get added to. Remember, the plus equal will get added to. And then we're going to say your account balance is savings.getBalance, and we're going to round it to 2 decimal places. We're going to put a dollar sign in front. And then we're going to say we get the amount to withdraw. So cash is equal to float input. How much would you like to withdraw? And then we're going to put print. I will withdraw that from your account, and we're going to do savings. Again, remember, this is the object itself, and we're going to call this method. We're going to pass the cash. Now remember, if it's more than what we have in our balance, it's going to say insufficient funds. And then we're going to print your account balance is savings.getBalance again, rounding to 2 decimal places. So pretty simple. Bank account has all of the code and methods inside of here. We basically all of the code inside the bank account is hidden from us. We really can't see it. We just know that now here's what's really nice is if I were to type bank account period, it basically, not there. That's not what I wanted. If I were to do savings, which is the bank account object, if I do a period, look at all the stuff that comes up. Here's my deposit. Here's my get balance. Here's my withdrawal. Notice the init shows up, but we don't have access to that because it's got the hashtag in front of it. And notice all these other items are there as well. Notice they all have 2 underscores in front of them. We do not have direct access to those. But just realize these are all part of the bank account object. These are items that come with objects from Python. They automatically come with Python. We're going to cover one of these tonight, the str. Okay? So that's what's kind of nice, and then you can pick the one you want and just hit the enter key on your keyboard, and it will basically take that. Okay, so if we go ahead and run this, this says enter your starting balance. I'm going to put 500. I was paid $250 this week. It says I will deposit that in your account. Your account balance is now 750. How much you'd like to withdraw? I'm going to say 400. And it says your account, I will I will withdraw that from your account. Your account balance is now $350. So, pretty cool. Again, what's nice about this is the class itself, the object itself, does all the heavy lifting. We just pass information to it. It does the calculations, and it basically returns the balance. Okay, bottom of page 539, we talk about this str method. Now that's underscore underscore str underscore underscore. So the value of this object attribute at a given moment. So basically, we'll tell what's going on with this object. So it's kind of the object in its current state. It displays the object state, automatically called when the object is passed as an argument to a print function. Automatically called when the object is passed as an argument to the str function. So if I were to say print the object, the str method is automatically called. Again, we can't call it directly because it is a hidden method. But we can, and the reason it's, now with methods, we have to put underscore underscore in front and underscore underscore in back. That makes it a hidden method. For data attributes, we just need the two underscores in front. So let's actually play around with this, and let's take a look at bank account 2. So bank account 2, pretty much the same. We've got class bank account. We've got our init. And notice it's got underscore underscore in front, underscore underscore in back. That means it's hidden. We've got our, we need to pass in a balance, and we're going to take whatever's in that balance and put it into our underscore underscore balance. We've got our deposit, which is the same. We've got our withdrawal, which is the same. We've got our get balance, which is the same. The only thing we've added now is this def underscore underscore str underscore underscore. And all we have is self, just the object itself. And so if I say print the object, this is automatically called. And it's going to return F, the balance is self balance, and then 2 decimal places. So it's got the $sign in front. So let's see what that looks like. We're going to open up the account test 2. And this is pretty much exactly like the account test, except we've got one more thing at the bottom. So we've got our starting balance, we've got our savings, and we create our savings, which is the object, a bank account 2 object. We ask for the pay, we add that to the pay as a deposit. We base how much you want to withdraw, we do that. And then at the very bottom, we just say print savings. Now when I say print, now savings is the object. Now when I say print savings, it's the first thing it's going to look for is underscore underscore str underscore underscore. If it doesn't exist, we'll see what happens if it doesn't exist. I'll do that in a second. So when we run this, I type in my beginning balance. How much should I get paid? I want to withdraw again. And then it says the balance is $350. So when I say print that, it automatically calls as str, which is the balance is $sign self, which is the object itself, dot underscore underscore balance, and it basically rounds to 2 decimal places. Okay? Now, if I were to, I'm going to comment these two things out, and I'm going to run it again, do my starting balance, how much I got paid, how much I want to withdraw, and now look what happens when I just print the object. It prints bank account 2 dot bank account object at, I know, so it basically says it's at this part in memory. Well, that's really not what we wanted. So again, if we say print the bank account, it's going to be looking for this str method, and that's what's going to be automatically executed. Okay. So now we have, on the bottom of page 542, we have working with instances. So an instance attribute belongs to a specific instance of a class. So at this point, we've created just one instance of a class. We created, again, we just created the bank account and the bank account 2 and a coin. And that's really all we've created, with just one instance. Many instances of a class are created. Each would have its own set of attributes. So we're going to create 3 coin attributes. We're going to create a coin 1, a coin 2, and a coin 3. And so let's see what that looks like. Yeah. So what they're showing here is coin 1 could have heads, coin 2 could have heads, coin 3 is going to have heads. And then when we run it, it might be tails, tails, heads, whatever the case may be. So let's take a look at what we mean by that. So I'm going to open up Coin Demo 5. And again, we import coin, so we're going to have the coin and its class, and we're going to create 3 instances, 3 separate instances of objects. So we're going to create a coin 1 object, which is, so I'm going to use the coin module, and I'm going to create off the coin class. Coin 2, coin class, coin 3. So when I execute lines 8, 9, and 10, I now have 3 instances of the coin object. And then I'm going to say I have 3 coins with these sides up. So I'm going to display coin 1 dot get side up, get side up, get side up from each instance. And again, it should be heads for each, because remember with the init, initializes it to heads. It's like we're putting the coin on our finger. So we got 3 people. So 3 separate people. They all have the heads facing up on their thumb, ready to go. Down here, now I'm tossing all 3 coins. I'm going to print a blank line. I'm going to say coin.toss, coin.toss, coin3.toss. So again, first person flips, second person flips, third person flips. And now it says now the sides are up, and it's going to basically get the side up from coin 1, coin 2, and coin 3. Okay? That's as easy as it gets. So we created 3 instances of objects from one class. So when I run it, so I have these 3 coins with these sides up, heads, heads, heads. I'm tossing all 3 coins. Now they're the sides up, heads, heads, heads. Let's run it again. Oh, look at that. Now it's got tails, tails, heads. Run it again. Tails, tails, heads. Heads, tails, heads. Heads, tails. A third one's always heads. There we go. Heads, tails, tails. So the whole point of that exercise is to let you know that you can create more than one instance from a class. So an instance of an object. Okay, on page 545, we've got a great in the spotlight. So it basically says, Wireless Solutions, Inc. has a business that sells cell phones and wireless services. You are a programmer in the company's IT department, and your team is designing a program to manage all of the cell phones. So basically, we got a cell phone. It's got three data attributes. We have the manufacturer, the model, and the retail price. And we want to be able to create as many cell phones as we can, or objects from that. So let's take a look at cell phone. So this is the class we're going to create it from. So here we've got cell phone. Notice it's got an uppercase C for the cell phone. That we always make sure the class name starts with uppercase letter. Here's our init. Notice we've got manufact, model, and price. And we've got 3 data attributes, manufact, model, and retail underscore price. And notice that the data attribute and the parameter being brought in can be the same exact name. That we don't have to keep it different. What the main focus here, or the main reason they're separated, is these underscores. And they went ahead and spelled out retail price. So when I create a cell phone object, I got to make sure I pass in the manufacturer, the model, and the price. And those 3 data attributes will be loaded with that data when this object is instantiated. I have a set manufacturer, I have a set model, I have a set retail. So I can actually call this and pass in the manufacturer. So if I need to change the manufacturer for something, I can do that by calling the set. I can do the set model, I can do the set retail price. And then I have a get manufact, get the model, and get the retail price. So I can actually set each one of those attributes, and I can get the data from each one of those data attributes. Okay, so let's take a look at cell phone test. So here I make sure I import the cell phone. Here's my def main. Do I have any other? Nope, just the one function. So I've got man equals input into manufacturer, mod equals input into the model number, retail equals input the retail price. We're making sure that's a float. Then I instantiate a phone object right here. So the phone object is equal to cell phone. So go to this code and basically get the cell phone class. And I'm going to pass the man, mod, and retail. So right here in my init program, there's the manufacturer, model, and price. Then I print, here are the data that you've entered. Manufacturer is a phone.getManufact, phone.getModel, phone.getRetailPrice. And that information is brought back and displayed. That's as simple as it gets. So let's go ahead and run this. And the manufacturer we'll say is iPhone. Model number is, we'll say it's a 15 plus. And the retail price is, we'll say is $7.99. And then it basically says, here's the data you entered. Manufacturer is iPhone, model number is 15 plus, and the retail price is $799.00. And it does that because of the 0.2 at the end of that print statement. So, now, the one thing they want to basically make sure you know is at the bottom of page 547 is these things called accessor and mutator methods. Now, accessor methods are what are called the gets. Now, the nickname that these are called getter statements. G-E-T-T-E-R, getter statements. So I've got a get manufact that'll get whatever's inside of that hidden field manufact. And I've got get model, and I've got get retail price. Then we have what are called mutator methods, which are these sets. And the nickname for those are called setters. There's a little note in the bottom of page 547. Mutator methods are sometimes called setters. Accessor methods are sometimes called getters. I wouldn't say sometimes. That's basically what they're called all the time, is getters and setters. So our setters allow us to set those fields if we need to, and getters allow us to get the data, the values from each one of those data items. Now on page 548, we need to store objects in a list. So not only are we going to create objects, but we're going to store those objects in a list. And so let's take a look at cell phone list. So we're going to use the same cell phone code. That's the great thing about objects, is that class can be used in all kinds of different areas, and we can use it in all different types of ways. So in this case, we're importing cell phone. We're going to create a list called phones. Phones equal make list. So basically that is a method down here, make list. Okay. So we got phones, which is going to be a list item. And down here it says phone list, and it's going to be equal to an empty list. And then we're going to say enter the data for 5 phones. So it says for count in range 1 to 6. So it's going to start at 1 and go to up to 6. So 1 through 5. We're going to print the phone number and string count. So the phone number, string count. So it's basically going to tell the count that we're currently at, which converts it to a string. So the first one's going to be phone number 1. Enter the manufacturer, enter the model number, enter the retail price. It's going to put it in demand, mod, and retail. We print a blank line. Then the next thing we do is we create a phone object. And that phone is equal to cellphone.cellphone man mod retail. So now we instantiated an object, and we loaded the default values for manufacturer, model, and retail. And then I say phone.list append phone. So what that's going to do, it's going to take the object phone and actually add it to the list. And then I say return the phone list. So for make list up here, we now have all of our 5 phones objects inside of this list. Then I'm going to say display, here's the data you entered, display list phones. So down here there's a method called, a function called display list, and there's phone list. So we pass the list of those 5 objects. Then I'm going to say for item and phone list. It's going to basically take each item, each object one at a time and put it into item. Then I'm going to say print item.get. So every time we go through this for loop, each item is going to be the object itself. So the first time through, it's going to grab the first object and get the manufacturer, get the model, get the retail price, print a blank line, and then basically come back to the second one, the third one, the fourth one, and the 5th one. So here's what's nice about this. We're creating 5 objects and we're putting them into a list. So the first manufacturer we'll say is Samsung, and it's an S24. Retail price is $749. Next one is iPhone. We'll say is a 15 plus, and retail price we'll say is $899. Next one we'll say is LG, and it's a T67. Retail price is $699. Number 4 we'll say is a Google. It's a Pixel. The retail price is $789. And the last one is basically, we'll say it's testing. And the model number is R98, and the retail price is $499. So when I get done, it then basically went through the display list, and there's our Samsung, and the price, Samsung price, Samsung price. Now I would have done this, I would have done a print F right here, and I would have done get retail price, colon, point to F, and I would have put a $sign in front. So I would have done that, so it had a $sign in front and then 2 decimal places. But that's just me. Okay, so now we're using lists to store objects in a list. Remember, lists can hold anything. Could have done a tuple. Okay, I think we already talked about accessor and mutator methods. Passing objects as arguments. Okay. Okay, the next in a spotlight on 552 is called the pickling your own objects. So now we're going to use the pickle to basically store those into a file. We can actually store objects in a file. So let's go ahead and open up the pickle cell phone. And what are we importing here? Importing pickle, and we're importing cell phone. Okay, so we need pickle. Remember, that was the previous chapter, so we can actually write it to a file. And we're going to say the file name is cellphones.dat. Then we're going to basically initialize a variable to control the loop. We're going to say again is equal to lowercase y. Then we're going to create our output file is equal to open file name WB. So we're writing the bytes to that file. We're going to say while again, here's the again up here, dot lower equals a y. We're going to say man is equal to input into the manufacturer, mod is into the retail, the model number, and retail is a float input at get the retail price. Then we're going to create we're going to instantiate an object, a phone object, and that's equal to cell phone. Again, this is calling the module, and this is the class. And we're going to pass in the man, mod, and retail, because remember the dot, the underscore, and net, underscore. We pass it those 3, and it basically sets those data attributes. Then I say pickle.dump phone output file. So it basically is going to write that object to the file. Then we're going to ask, do you have any more phone data? Yes or no. And if we say yes, it's going to go ahead and create another phone object, and then we're going to write that to the file. Once we're done entering all those, it's going to close the file, and then we're going to say the data was written to file name. Again, file name is a global variable. And that's it. So we're going to create the file. That's all we're going to do. So I go ahead and run this, and we'll go ahead and say Samsung. We'll say the S24, oh, 34, whatever, $7.99. We're going to say yes. Let's do an iPhone. We'll do a 15 Plus, and that's $8.99. And we'll do one more. We'll do an LG. Is a T78, and that is $6.99. I'm going to say no here. The data was written to the cellphone.dat. Now again, if I come up here and open up this cellphone DAT, we can kind of see some data in there, but a lot of it's going to be a lot of unprintable characters, because again, these are bytecodes. So what we want to do now is open up our unpickle program. So this guy is going to read the data. So again, we've got our import pickle and import cell phone. We've got our file name, cellphone.data. We're going to say end of file equals false. We're going to go ahead and open our input file for read bytes. And while not end of file, so while this is not true, we're going to basically say phone is, so this is the object. This is the phone object. Wow. Are we not creating a phone object? Apparently not. So apparently phone is going to, so apparently just reading the file, reading that one line of data out of that file, it's going to know it's an object, and it's going to create a phone object. Now you'll notice that this import cell phone is grayed out. That means it's not used. If we use the actual cell phone data, then it would basically be orange and white. But since it's grayed out, that means, yeah, I've imported it, but not doing anything with it. So apparently when it reads that line of code, the first line of code out of that pickle file, it's going to basically, it knows it's an object. Then I'm going to say display data phone. So I passed the phone object down here. So here's the phone object being played. And we're going to go ahead and say phone.getManufact, phone.getModel, and phone.getRetailPrice. Then it's going to read the next one. The next one, it's going to do that until we hit the end of file error. And then we're going to say end of file equals true. And it's going to drop out of that. And it's going to close the file. And we're going to be done. So let's go ahead and run it. And there it is. There's our manufacturer, Samsung, S34, $7.99, iPhone 15 Plus, $8.99, and then there's our manufacturer, LG, a T78, $6.99. So I can run this again. I'll get the same exact data because it keeps reading that same data out of that file. Next thing is in the Spotlight, storing objects in a dictionary. So we've seen how we can store, we saw we could store objects into a list. We've seen how we can store objects into a pickle file. And now we're going to actually store objects into a dictionary. So let's open up Contact. And this is a class. Here's our init file. And it's expecting to be passed a name, a phone, and an email. When those are loaded in, we're going to basically load those up into the data attributes, name, phone, and email. Then we've got our setters, set name, set phone, set email. We've got our getters, get name, get phone, get email. We have our str, so if we say print the object, this will get executed, and it's going to go ahead and return the name, the phone, and the email. It's going to have name colon and then whatever's in the name, phone colon whatever's in the phone, and email colon whatever's in the phone. Notice we've got a /n at the end, so it's going to be these all be on 3 separate lines. Okay. Now let's take a look at the contact manager. So this guy's going to import. It's going to import contact and pickle, so I'm going to write into a file, but we're going to be writing them as a dictionary. So we got our contacts.dat. Here's our main. We got mycontacts.loadContacts. So I come down here, and here's load contacts. And so, so contact's being used somewhere. Let's see where it's being used. So I got my input file. Open the input file for read bytes. Here's my contact dict. So my dictionary is equal to pickle.load input file. So there's my dictionary. It's going to unpickle, so it's going to read it. And then I'm going to close it. So it's going to read everything into the dictionary. If there's an I/O error, it's going to make sure that. So basically what happens is, if I try to open this guy and the file is empty, it's going to hit this exception and basically go ahead and make the dictionary an empty dictionary. And that's going to return contact dictionary. So we get my contacts, so my contacts is a dictionary. We're going to say choice is equal to 0, and then we're going to basically display a menu. While choice is not equal quit. Now, if you notice up here, we've got some global variables. Lookup is equal to 1, add is equal to 2, change 3, delete 4, and quit is 5. So as long as it's not equal to 5, we're going to say choice is equal to get menu choice, which is another function down here, which displays print, menu, an underscore, and 1 is look up a contact. So it basically displays a menu for us to choose from. We're going to enter 1 if we want to look up a contact, 2 if we want to add, so on and so forth. So then we say if choice is equal to lookup, we're going to call the lookup and pass my contacts to it. So here's my contacts, and it's going to say enter a name, print contacts, get name. So now notice this is using a dictionary. So we're saying mycontacts.get name. If it's found, it's going to print it. If it's not found, it's going to say that name is not found. And then we're going to say, if we do an add, it's going to call this add function. So add my contacts, it's going to say name is equal to input name, phone input phone. And so it's going to ask us to type those in. So we can actually add data to it. And then the entry is contact.my. So this is where it creates a contact object. Okay. And right here it gets instantiated, and we're going to pass a name, phone, and email. So when line 102 gets executed, we now have an entry object, which is a contact object. And it's going to have those 3 data attributes filled. It's going to say if name not in my contacts, contacts name entry. So it's going to basically, if the name does not exist in the dictionary, add it as a key with the dictionary object. So we're basically doing this. If it doesn't already exist in the contact list, we're going to go ahead and add it to the contact dictionary. If it does exist already, we're going to say, sorry, that name already exists. If we do change, so this is doing an add, and the add will not let us overwrite an existing item. If we have change my contacts, it's going to ask for a name. Then we're going to basically enter a phone number and enter an email address. Then we're going to say entry, so we're going to create another entry object. And we're going to say my contact's name, so we're going to basically make the my contact's name equal entry. So what we're basically saying is, if that name exists, we're going to basically put that in there. So it basically says if name in my contacts. So if that name exists, we're going to basically update it with a new object. Just basically allows us to change the phone and email. We're not going to change the name. If it doesn't exist, we're going to say, sorry, that name is not found. If we need to delete a contact, we're going to basically pass my contacts in the dictionary. We're going to say name, enter a name. If the name in my contacts, if that name exists, we're going to use the del my contacts, and then we're going to use the key name. And we're going to say entry deleted. If that name doesn't exist, we're going to display that name is not found. Then if we want to save our contracts, we're going to basically pass the contracts dictionary. We're going to basically say output file, file name, write the bytes. We're going to do a dump of my contacts to the output file, and we're going to close it. So once we open it up, and we basically we can either do an add, we can do a change, or we can do a delete. Once we do that inside the dictionary, then we're going to rewrite it back to the file. So the first thing we do is we read the file, we do all of our additions, changes, and deletes, and then we write back to the file. That's as simple as it gets. Again, we're creating objects, we're using the pickle file, and we're using a dictionary. So let's go ahead and run this. So let me expand this a little bit right here. So then you look up a contact, add a new contact. So we're going to actually do a to add, and we're going to type in Steve. His phone is, we'll just say 555-1111, and email is steve@email.com. And we're going to add another contact is Julie, and 555-2222, and Julie@email.com. And we'll do another add, and we'll say is Sally, and her phone number is 555-3333, and email is Sally@email.com. And then we'll say, I want to look up a contact, and I'm going to type in Julie, and it brings back Julie's phone number, and Julie's email. Oh, I want to change an existing, so I'm going to type in a 3. I'm going to type in Julie. Julie just changed her phone number to 555-6666, and her email is now Julie@gmail.com. So now if I do a lookup contact, I can do Julie, and there's Julie's new phone number and Julie's new email address. I want to delete someone, so I'm going to delete Sally. And now when I do a lookup and I type in Sally, it comes back and says that name is not found. So now when I do a 5, it basically just wrote that file, that pickle file, out to the file itself. Okay. If I look at contacts DAT, we can see there's a whole lot of stuff in there. Well, see, wow, I see a lot of stuff in there. Must be stuff I used. I've been creating this before. Wow, I didn't delete anything. Huh. Wow, okay. That's probably when I was playing around with it earlier. Okay. So that one is pretty complex. We had an object that we wrote to a dictionary, and then we wrote that dictionary to a file. Pretty cool. Okay, now this last part I'm not gonna cover in detail, but basically we have this thing called a UML document, or UML, and basically this is more for documentation. And what we do is, right here, we put the class name in the first box. Data attributes go here, and the methods are listed here. So here we've got coin, and our data attribute, the only one we have is __side up. Here's our init method. Okay. We've got the init method, we've got the toss, and we've got the get side up. And since we have the underscore, 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 that means it is a hidden method. So I'm not going to go through this. What they do is they've got this problem where Joe's Auto Body Shop or Joe's Garage wants us to create a particular program. They've got this thing where George basically says, find it. It's got this big long paragraph, and we break down all of the different pieces and parts, and we get it basically narrowed down to 3 separate classes. Okay, and those classes are, probably it's easier to just look at the code. And those classes are car, customer, and service quote. So let's take a look at car. So we got the car class, and the car is going to have 3 data attributes: make, model, and year. Okay. We've got our setters, we've got our getters. We don't have any str function. We have customer, which basically has name, address, and phone. Again, we got our init that basically loads those 3 data attributes. We have to pass something to them. And then we got our setters, we've got our getters. I do want to point out that you'll notice I've got this one usage, and then it's got a blank line right here. This is something that's built into PyCharm, so you can kind of ignore it, but it's basically saying that this is only used once. Again, don't worry about it too much. Because if we were to look this in any other type of code, those wouldn't show up. They only show up in PyCharm. And then the last one is the service quote. And in there we have a constant called tax rate, which is 0.05. We've got our class service quote. And this is kind of nice. Notice that we can have constants inside of a class. Well, in this case, it's outside of a class, but it's inside of the module itself. So we've got our service quote. We've got P charge, which is parts charge, and L charge, which is labor charge. So we load those 2 data attributes. We've got our 2 setters. We've got our 2 getters. And then we got one more method called get total charges, where we take the parts charge and add the labor charge, and then we basically plus divide the parts charge times the tax rate. So we can't charge taxes on the labor. We can only do the tax on the parts charges. Now, the one thing this book didn't do is create a program to utilize these 3. So what I did, and you can actually download this and some of the code we have in the classroom, and I call it Chap 10 Joe's Auto. So if you open that up, let me bring this down a little bit. So let's take a look. I've imported car, I've imported customer, and imported service quote. Here's my main. I create 3 empty lists: custs, autos, and serve queues. And then what I'm going to do is, instead of asking the user for all of this data, I just went ahead and just said cust.append. Okay, so this custs list dot append, I'm going to say customer.customer, so it's look in the customer method or module, and we're going to create so basically what we're doing is we're creating a customer object, and we're going to actually just throw in Mark, 123 Main, Illinois, and here is the phone number. Now notice, again, PyCharm does this as well, which is kind of nice in this case. Again, if we were to open these up in any other type of editor, these would not show up. But it's saying, hey, here's the name attribute, the address, and the phone. Here's the autos.append, so it creates a car object called BMW M3 2020. And here's the service quote, 234 times 50.56 and 175.00. Now, I put this number here, so if you want to play around with this, you can actually duplicate these 3 lines and actually add more. Because then what I do is I say for X in range length of customers, so how many customers there are in the list, it's going to execute this for loop. So if you have like 3 more in here, it's going to execute this for loop 3 times. It's going to say the customer costs X, so the X is the numeric value that's being created. So the first time through is a 1, then 2, then 3. So if there's the length is 3, it's going to go 1, 2, 3. And it's going to say get name, so it's going to call the object customer, get the name, at their address, needs to be called at get phone. Then it's going to print cust get name has get year, get make, and get model. So it's going to display what the customer's name is and what they have. Then it's going to say the customer name, the customer name's bill, and it's going to then have labor, get the labor charge, part, get the parts charge. Notice I'm basically rounded to 2 decimal places. And then the grand total is get the total charges. I notice I put in parentheses back over here, tax included. So if we run this, boom, there it is. The customer Mark at 123 Main, Illinois needs to be called at that phone number. Mark has a 2020 BMW M3. Mark's bill, labor 175, parts 234.56, and the grand total is 421.29, and that's with tax included. Okay, I highly suggest you play around with this. Play around with any of the code, experiment, play around. Again, if you have any questions, give me a call. We can Zoom. We can talk on the phone however you need to. We can basically, I can get you the help that you need if you basically need it. Okay, we'll see you next chapter.